This video will take a look at how to convert different units of measurement that we see in pharmacy using dimensional analysis. So let's just jump right in with an example. Let's say you want to convert 112 micrograms of levothyroxine into milligrams of levothyroxine. Now, levothyroxine is a thyroid hormone that we give to patients who have low thyroid hormone. Now, to convert 112 micrograms into milligrams, we're going to need to use a conversion factor that relates micrograms to milligrams. Now, we know from the video yesterday that there are 1,000 micrograms in 1 milligram. We need to create a conversion factor between these two. And the conversion factor will just be a fraction that divides the two quantities. So we can have 1,000 micrograms divided by 1 milligram, or 1 milligram divided by 1,000 micrograms. And the conversion factor that you want to use depends on what it is that you want to find. Now, we want to find milligrams, and we want to get rid of micrograms. So to get rid of micrograms, you want to put micrograms on the bottom, put milligrams on the top. This will cancel out micrograms because you're taking micrograms and dividing by micrograms, so they'll cancel out. So the conversion factor that we're going to use is this one right here. There's 1,000 micrograms in 1 gram. So we'll take 112 and we'll divide by 1,000 and we get 0.112 milligram. So 112 micrograms of levothyroxine is the same thing as 0.112 milligram of levothyroxine. So this here is your answer. Let's take a look at another example of using dimensional analysis. So let's say that we need to make a compound. And in this compound, we need to dispense 12 tablets where each tablet contains 500 milligrams of metronidazole. So we need 12 tablets where each tablet has 500 milligrams of metronidazole. Metronidazole is an antibiotic that's good for anaerobic bacteria. We want to convert from milligrams into grams. We want to know what the total weight is in grams. So to do this, we need to find what the total weight is first in milligrams. So we'll take 12, because there's 12 tablets, we'll multiply it by 500, and we get a total weight of 6,000 milligrams. Now what we want to do next is convert the milligrams into the grams. And we need to think of a conversion factor that relates milligrams and grams. Well, we know that there's 1,000 milligrams in 1 gram. We'll put milligrams on the bottom and grams on the top so we can get rid of milligrams. There's 1,000 milligrams in 1 gram, so we just simply divide 6,000 by 1,000, and we get a total weight of 6 grams. So this is the total amount of metronidazole we need in order to make the compound. Let's take a look at another example. And this example is going to show you how you can use two different conversion factors in order to solve a problem. So let's say you have a patient that comes into a diabetic clinic, and the patient's blood glucose is 234 milligrams per deciliter. What we want to do is convert this measurement into grams per liter. Okay, so to convert milligrams per deciliter into grams per liter, we're going to need two different conversion factors. We need one that relates milligrams and grams, and one that relates deciliters and liters. So we'll start out by first writing what we want to convert. And it's best if you put this into a fraction. We have 234 milligrams in 1 deciliter. And it doesn't matter which unit you want to convert first. Let's go ahead and first convert the milligrams into grams. So we'll put milligrams on the bottom, so it cancels out, grams on the top. And we know that there's 1,000 milligrams in 1 gram. And we need to next do another conversion factor, because now we've got grams per deciliter, we want grams per liter. So our next conversion, we need to get rid of deciliters. So we'll put deciliters this time on the top, because we have deciliters divide by deciliters, and so they'll cancel out. We know that there's 10 deciliters in 1 liter. And so when we multiply this out, we'll have 234 times 10 divided by 1,000. And we'll be left with grams per liter. So 234 times 10 is 2,340 grams divided by 1,000 liters. We can simplify this fraction, and we're left with 2.34 grams per liter. And that's your answer. So 234 milligrams per deciliter is the same thing as 2.34 grams per liter. Okay. Now let's take a look at an example where you have to convert between the two systems, between the metric system and the customary system. So let's say a patient comes into a hospital, and the patient has a height of 5 foot 10 inches, and they weigh 198 pounds. So we want to convert the height to centimeters and the weight to kilograms. And we do this for dosing purposes, because the doses of many drugs can either be dosed by weight, which most of them are dosed by weight, and some drugs, I guess, could be dosed by height, but most are dosed by weight. So we'll first convert into centimeters, and to do this, we need a conversion factor between either inches in centimeters or feet in centimeters. And recall from the last video that there's 2.54 centimeters in 1 inch. So we need to get this height into just inches so we can convert into centimeters. So the person is 5 feet. We'll convert the feet to inches. 1 foot has 12 inches. So this is 60 inches. And we'll add the 10 inches in the original height onto that. So we get 70 inches. We can now convert 70 inches into centimeters. We know that there's 2.54 centimeters in 1 inch. Put inches again on the bottom so they'll cancel out. And when you multiply this through, you should come up with 177.8 centimeters for the patient's height. Now let's go ahead and convert their weight. Oops. Patient weighs 198 pounds. We need to convert to kilograms. So we know that there's 2.2 pounds in 1 kilogram. So we'll put pounds on the bottom and we'll put kilograms on the top. Pounds will cancel out. 2.2 pounds per 1 kilogram. And when you do this division, you should come up with 90 kilograms. So the patient's weight, if they weigh 198 pounds, is the same thing as 90 kilograms. I hope these examples have been helpful to you when trying to convert units that we use in pharmacy practice using dimensional analysis.